Awesome. So after the compilation and interpretation and the Java virtual machine nodes, you'll notice that there's quite a few notes about how to set up project files. And I just want to show you how I usually do it on my end. Again, can vary as you get more good at it and you do it more often. But to get started, what we could do is go to File, New, Java Project. And inside of this Java project, I'm just going to call this a Hello World project. And I'm not going to create a module info Java file. And I'm just going to go ahead and hit next. Inside of there is fine. You can just go ahead and hit finish as well. And if I open up this Java project, you can see I have a source folder. I have a default package in here. So after the Java virtual machine bytecode information, you'll see a lot of notes about setting up projects. And I just want to give you a visualization of doing this ourselves. So what I'm going to go do is go to File, New, and Java project. And inside of this Java project, I'm just going to say hello project. And I'm not going to click the create module info Java file. I'm just going to hit finish. And inside of here, you'll see a source folder with nothing inside of it. Now, every time you make a class in Java, a class file, it's going to want to be stored in a package. If you don't declare a package and, for instance, go to new and class like that, it will give you a default package. We don't really want that because it causes a few issues. So we're just going to go ahead and hit package for our sake here. So let's go to source, make a new package. And then I'm just going to go ahead and say hello world package. And again, with conventions and everything, based on how you want to do it, you can start packages with lowercase letters and everything as well. It even said that there too, but for our purposes here, I just want to show you the process of making it up. And now inside of this package, if you right click on it, go to new class, you can then say hello world class. And then always for our class here, always make sure that you just generate the public static void method for ourselves. And I'm going to hit finish, and then I'm going to run it. Now, if I go ahead and just copy this over to here, you'll notice at the very top that if I run this code, we should be good to go. Cool. So this is essentially how we could set up our new packages and so forth as well. And I want to show one more thing about some errors that I ran into when I was starting to learn how to code and stuff as well. You'll see here that I'm trying to run this file over here. And if I don't have any main method again, it's going to give me this error there. You might notice that when you make a new file and you're trying to run it and it's running a different file's main method, it's because that file is most likely missing a main method. So just be on the lookout for that. Now we can go ahead and talk a bit about variables inside of our Java file. To do that, I'm going to go ahead and make a new Java class. And I'm just going to call this types. And I'm going to make my static main method there. And I want to go ahead and try to declare some variables. So again, we have our primitive types that we see in each language. And the way that Java tells us how to make these is by the variable type. So you need to define the type it's going to be, and then the name. So let's just say age, let's just say 60. And now we can see here that I have a variable that is of a type integer that is set to 60. And I can go ahead and just print out this age here. And again, you'll see here that the age that I'm getting here is from up here. And if I hit play, I get 60. I could change this to 65, and then I get 65 there. Now, for practice, you can go ahead and set up each of these. In Java, the string type is with a capital S. So I'm going to say string name is equal to John. I'm not 65 though. And then I'm going to say Boolean is, let's just say, let's call it test is equal to false. And then we have character test2. Let's call this to A, so forth. And those again are kind of our more primitive types there. And for the floats, or the double as we like to call them, let's call it test3. Could put it as 50.4 with a semicolon. And again, the string, you'll see strings more often. It won't be one of the very primitive ones because a string in Java is going to be an array of cars. But again, it's pretty similar like you've seen in Python, these same type of types there. So again, what I want to do really quick is just go ahead and show everyone what these look like when you print them out there. We can see that we have these values set up. There's another way you can set a variable. So what you could do instead is say int, let's see, foo. And after I say foo up there, I could set foo is equal to 5. And then the same thing can apply here. If I go ahead and print out foo, it should print out 5 at the bottom here. Cool. So now we're going ahead and making up variables and we're setting them the values. Remember, this is all my main method. You could also go ahead and some logic, or excuse me, some programs you might see earlier, you can actually declare variables out here like so. And now you'll see here that it's actually at a different level or scope of our variable, and it's actually a bit blue as well. Eclipse is very nice with color coding. I don't want to delve too far into that yet, but just notice that that is one way that we could do it as well. And again, you definitely don't want to redeclare variables like this here, because Java will throw a fit about that. So we want to make sure that it's since it's already declared once, you're not going to duplicate it. But again, you can always redeclare variables like so. And if I go ahead and print out, I get a 5 up here after it's set, and then down here I get a 6. So again, you don't want to declare the variables multiple times, but you can change their values like so. Now I want to talk a bit about arithmetic operations. Again, we have the pretty much basic ones that every language has: addition, subtraction, multiplication, division, and modulus. And we can go ahead and just use the examples from the notes here. I'll say num1 is equal to, let's say, 5. And then I'm going to say my num2 is equal to 10 here. And then I'm just going to go ahead and print out a few arithmetic operations that I can do with both of these. So if I go ahead, do this a few times, as expected, we'll probably get similar values here. Cool. So essentially stuff that we expected already. Oops, that should be multiplication there. And we can see we get these different values too. And now you may notice that we had the, in Python and other languages, you had the conversions. It's very easy to do conversions in some of these languages. In Java, for example, if we actually declare a double, which is a float in Python, similar type of idea, I'm going to call it num3. I'm going to put it to 50.5 here. We can actually do certain arithmetic operations between two different types without Java getting annoyed about it. So we, even though Java is a bit statically typed in comparison to Python, we can actually go ahead and just do the division, or excuse me, do subtraction, multiplication, and these arithmetic operations, even though num3 is a different type to num1. The next session talks a bit about the naming of variables that we like to call them as identifiers. Identifiers is what you're going to be seeing in the books and other courses at DePaul as well. Usually we want to make sure that identifiers are pretty visualized easily, and there's a few conventions that we can use with them. So for an identifier of int, I could say number like so, is equal to 5. I can also do int underscore number equal to 5 as well. And I can also do int lowercase number is equal to 5. So we can see that we can play around with the numbers as well. What you can't do though is use things like this. So if you can see here, int void is going to give me an error. And why does that give me an error? It is an invalid variable declarator ID. So that's an invalid identifier because it is used by Java. Java kind of has a monopoly on that, right? Some other ones might be public, private as well. And so if you ever wanted to use that name for whatever reason, you can do an underscore public and you should be good to go, or an underscore private. It should be good to go as well. You also cannot start off items like this. You can't start a variable with a number. If you do need a number variable, you can do an underscore, but please don't do that, as you'll probably make other developers a bit angry about that. Our next portion, I want to talk a bit about Boolean expressions and items that we're pretty familiar with on that area as well. I'm going to go ahead and create a new class. I'm just going to call this Booleans here. Make sure that I make my public static void method. And I'm going to go ahead and just showcase some of these areas that we already looked at already. Again, I have the general idea of what each of these expressions are on the screen there for us, but I also want to show it in code as well. So the easiest way to kind of practice with these Boolean expressions is to show off what variables do to each other. What I want to do here is just go ahead in a very basic example. I'm just going to say num1 is equal to 10. And then I'm going to go ahead and say num2 is equal to 11. Now, what we can try to do in our Java code is actually just make some print statements here and add in a Boolean expression inside of them. Anyway, so we can see here that the num1 is less than num2. We get the true there because it is. And what happens if I go ahead and try out num1 is greater than num2? We now see that one is false. So again, pretty straightforward, right? Let's go ahead and try to add in another number, num3, and let's also set this to 10. Now I can say here, is num1 less than num3? It's not, so that's going to be false. Is num1 less than or equal to num3? It is equal to, so that's going to be true. Same idea here. Is num1 greater than num3? It's not. Is num1 greater than or equal to num3? It is. Now for the last one that we can try here with num3 and num1 as well is the equals to. If I go ahead and let me delete this, and I'll actually show everyone a little quick trick here. If you're coding away in your Java environment, you may have remembered that in Python, let me pull up my Python one more time, the pound sign is what gives us the comma. In Java, it is actually 2 forward slashes. So it'll be forward slash twice. That gives us the commented out item there. And here, if I go ahead and hit play with the last guy, we see we get a true at the very bottom. And if I go ahead and try to put a not equals to, what do we think it might be? Most likely false, right? And we're right. So another cool thing here, if these tests if this is looking a bit like convoluted to you on your end, what you can do here is highlight a few lines of code, hold the control key, and then press the forward slash button, and it will actually comment out all these lines of code for you. If you go ahead and have them highlighted still and press it again, it will uncomment them. All right, so I made two different Booleans here. One's going to be true, one's going to be false. And I just wanted to showcase what this looks like in the code based on the chart that's on the notes as well. So I can go ahead, and the first one that we're going to usually use is the AND symbol. So if bool1 and bool2, and the way that we can actually write that in Java code is a double ampersand symbol. So bool1 and, or I always say the and, but this means and bool2 will signal to us that we're asking for the expression that is returned from saying true and false. Now, based on our logic here, if something is true and false, then the answer is false. Now, if we go ahead and try to use an OR down here, and the way that we can use an OR is by going Shift on your keyboard, and then the sign above your Enter keyboard, which is the vertical sign there, Shift bool1 or bool2, what we get then is a true, because we're saying true or false. That's essentially what we're saying there. Now, there's one more that I want to show off, which is the negation or the not. And what this means is that if I go ahead and type in bool1 down here, we'll see I get a true. If I go ahead and copy this and I put the exclamation point in front of it, I will get a false. Because essentially what a not is, an exclamation point, is the inverse of it. So if my bool2 is a false, what do folks think I will get if I do a not bool2? A true, because what's the opposite of a false is a true. So with this being said, how do I go ahead and get this statement up here, which is evaluating to false to be true? Well, if we remember from our chart, an and needs both things to be true for the entire statement to be true, right? And right now I have my bool1, which is true, and my bool2, which is false. What I can do here is go ahead and add in an exclamation point. And what does that tell us now? It's actually true. Because essentially what is happening is give me the output of true and not false, which is true, which gives us the true again. Again, this can get a little convoluted with just using the Booleans. So there is a few files that I'll be providing, and there'll be an extra supplemental video just walking through a few of them that you can watch as well with each of these sections. Great. For our next section here, I want to talk a bit about the random class in Java and how we can use that to make some interesting programs. So what I'm going to do is make a new class. And I'm just going to call this random practice. Again, the names don't matter as much, just as long as you checkmark this main method there. And inside of here, here's one more trick. If you have too many open, you can hit close tabs to the left. And inside of here, once you go ahead and open up this random practice item, you will be able to do a few things using this. So what I'm going to do is just make a new print statement. And what I'm going to type in is the word math. And after that word, math, and you can see here that it's inside of java.lang. I'm going to put a dot, and then I'm going to type out the word random. Now, here's a really nice feature of Java that's a bit more accessible than Python sometimes. If you actually hover over it, it will give you an exact rundown of what this does. So it's kind of doing my job for me, but I'll help read us through it. What math.random does is returns a double value with a positive sign greater than or equal to 0.0 and less than 1.0. Now, this is a pseudo-randomly chosen number. So essentially what this is going to return to us is values between 0.0 and 0.999 repeating. In the notes, it goes the exact number there. But if I hit play here, we'll notice that I get a big number there. I get a big number there, but we'll see that it's essentially a randomized number there. Now, this is very useful for simulating, like, as the notes say, traffic patterns or games or any type of simulation of kind of randomness that you would like. Again, this is actually determined by an algorithm inside of our code, so it's not truly random. It's not an actual source of randomness, but it is pseudo-random, and it's good enough for our purposes. Now, the notes talk about this as well, but I just want to show it in action. If you want to increase essentially the range that you're going from, you can use the number in front of it and times it by that math random. So if I want to go from a range of 0 to 5, I can do system.println 5 times that one. And the reason this is happening is because I am now multiplying that more randomized number in the range of 0 to 1 by another number there. So for our next step, we'll notice that if you're playing a card or a dice game and someone tells you that the die you got was 3.8788, you might have a conniption, right? That doesn't really make sense. So the way that we can use this formula in order to actually get a value between a range of values that we want to use is by going ahead and transforming this formula using a few little tricks here. So the first trick that we're going to do is go ahead and fill in this section here with 2 parentheses. And what I want to do after that is go ahead and transform this into an integer. And what transforming it into an integer would do, converting it into an integer will make it a whole number for us. So if I hit play now, you'll notice I actually got a 0, and then I got a 1, and I got a 0 again. I got a 2 that time. But you notice if you keep playing, if you keep hitting these numbers, it won't actually take you into that 5th die. So if I want a die, or that's 1 to 5, I'm not able to get it here. So what we need to do is actually add in a 1 at the start of it as well. So if I go ahead and play this now, I have the chance to get a 5, and I just did there. If you didn't add in this 1 on there, you would never be able to get the 5 there. And that's because this converts us into a range between 0 and 5, and the 5 is exclusive, so we never have the 5, and adding on that 1 will boost us up to that 5. Now, what if I want to play with a 6-sided die? I can add this, make it a 6. See if I can get a 6 here. There we go. What if I want to make this, let's say you're a 20-sided die. Let's say you're making like a Dungeons and Dragons type of game. We could see here I can keep rolling, and then I can get the higher numbers, right? So again, I won't keep you here to keep hit and play here, but these are different ways that you can convert it into a type of randomness.